So a few days ago, I was on one of Nathan Oakley's debate panels just to present this image, and picked up a bunch of subs because of that. So I thought, I should probably do science things every now and then for those people. So I decided to show the same image here and see if I can remember all the stuff I said, but it really isn't very complicated. It's, first of all, like you can see in the description, geocentrism assumes all the luminaries revolve around the Earth, which does not spin or move. Now, as far as why I don't believe the Earth spins or moves, is primarily because in the sun video that I have linked in the description, I have a whole list of my most comprehensive cosmology videos. On the sun one, it showed that the sun rotates the wrong way if sun movement is caused by camera movement, by Earth movement. So since it moves the wrong way, and since if it was moving the other way to make that rotation make sense, then the sun would be rising in the west, and that doesn't happen. So therefore, it isn't our viewpoint that makes it appear like the sun is moving. The sun has to actually be moving. And the way it moves, it rotates the wrong way, so it can't be due to Earth spin. But, so that is basically what geocentrism is, that the Earth is the stable center, the floor of the universe, however big you want to say the universe is, and everything revolves around it. It doesn't have to revolve underneath. It could be something like, if some people have modeled that in one of the other links there on perspective and luminaries in the description, as like turn a bowl upside down and put a bunch of little star points on it and kind of roll it around the surface, and you'll have an idea of how the luminaries might move. But in my sun video, you would also see how the fact that there might and maybe is lens I don't say capabilities, but characteristics between at least the sun and the surface of the Earth, and probably all the other luminaries as well. So check those out. And the thing is that this is a package deal. You put all these things together. And of course, there's a link in the description for biblical cosmology, which shows that this is what the Bible absolutely describes the Earth as. It never describes it as moving. And then we have, of course, things like Joshua's long day and Hezekiah's sundial going backwards 3 hours. And this is just really takes more of a stretch, more of a belief in extreme miracles than it does for the Earth being stable, the way that the Bible describes it. But anyway, what I got on this image here is that if you take 3 different geocentric Earth shapes, you would be able to determine which one is accurate by what kind of data points you could collect on where the sun goes from 1 hour to the next hour. And I'd pick that spot from eastern Canada to the southern part of South America as just a place that is fairly populated all along the way, well, most of the way, and somewhat easy to reach as far as, being populated. You could have people there who would observe, take note of their position on at least the 4 corners of the shape, and hopefully points along the way. If the Earth is a flat square, then you would expect to have a rectangle, a vertical rectangle like that, if you see on the screen there. And if the Earth is a flat disk, you would expect more of the cone shape that you have there in the center of the image. It would be much narrower at the northern end than it would be at the southern end, and you would have a steady increase in distance for the sun to travel 1 hour as you went south. And hopefully as far apart as possible. We're looking for something beyond the tropics if it's at all possible. And those tropic lines on those maps are not terribly accurate. They're just there for proof of concept. And of course, the one on the right, because more geocentrists believe in a ball Earth. Maybe that's changing, I don't know. But if you take that same time zone, basically, it should be the same distance on the north and south extremes, but wider in the middle. Now, the middle is going to be kind of hard to reach there, but you can see it. It kind of goes on the top of South America. So conceivably, this could be measured on the Earth's surface, and it would tell you which shape you're dealing with. And it has nothing to do, actually, with proving the size of the universe or anything like that. It just would say which of those three shapes is more accurate. Okay, so we've got the ball included there. And so that doesn't even rule out standard cosmology. You could, if you got that shape, you're at least dealing with a ball, one way or another, whether it's geocentric or not. So that's what that image is about. And again, check out the links in the description. Assuming most of you will only see this later. And the thing is that as far as we know, of any non-agency balloon launches or anything like that have gone up to about, I think the highest I've seen is 120,000 feet, which is about 20 miles or so, it still appears flat. And the sun always appears just a little above. It's, no matter when and where they launch a balloon, the sun always appears about the same. And the moon is a tiny dot. So the thing is that there is no observable, provable curvature at any altitude up to about 20 miles. Hey, Mark? So because of that, so far, unless we can get farther away, we could rule out any either convex or concave shape because they both require curvature. And if we don't see curvature, then it can't be either of those. And that would leave us with a flat surface. So then that's why I did this comparison between at least two flat surfaces, flat shapes. And it really is, as far as the flat shapes go, reducible to only two, because I know there are diamond maps, there are heart maps, and all sorts of things. All you would have to do is an experiment like this, or not an experiment, but a measurement like this, and you could see whether or not it's any particular shape. All you have to do is take the same data points and compare them, and you would have some idea. If it doesn't fit either of the two flat ones I have on the screen, then maybe it is time to look at one of those other maps. But what all the flat, non-circular maps have in common is they're all Pac-Man maps. Okay, Pac-Man, if anybody doesn't know, of course, is that you go off one side of the screen and magically appear at the other, which would have to be the case, and seamlessly so, without you being aware of it, because people have gone east to west all around the Earth many times. Not so much pole to pole. That really hasn't been verified by anybody trustworthy. And you could easily do a U-turn at one of the poles and not really know it, because going by a compass is pretty hard at those points because of the nature of magnetic fields. But yeah, you could look at the stars, but again, especially at the North Pole, if you're looking at straight up at Polaris and the stars are just twirling around, how are you going to find your direction? So how do you know whether you went all the way across? I don't know. But anyway, the point is that the problem with Pac-Man maps is Pac-Man. It's a deus ex machina. It goes to the machine, the thing that solves the problem that's like playing a wild card in a card game. You just none of the rules matter at that point. You have a solution that nobody can verify, nobody can test. It just has to be. So that's my problem with those kind of maps. It's not required on the disk map. So it has that advantage, the disk shape does. But the problem is, a lot of people will say the problem with the circular map is that since the sun moves 15 degrees per hour everywhere, which is something you can verify with sundials, the shadow at least moves 15 degrees per hour, then supposedly on a disk map, the sun would have to move faster as you go south, which is to the outer edge. But we can account for those sorts of things with various types of lenses or other distortions such as magnetic distortion. And it depends on Earth's shape, but of course the point is that the disk map doesn't necessarily suffer a fatal flaw at that point, in my opinion. Hey, Ryan. So that's just some ideas I've been kind of rolling around in my head about just going from geocentrism, but again, it doesn't rule out the Earth being evolved to be a geocentrist, but those shaded areas would give us a pretty good push in one direction or another on the shape of the Earth if we could get a lot of data points, as many as possible, along that shaded area or even inside of it. That's the distance that the Earth or the Sun should travel in 1 hour, and that part of the world happens to have some landmasses, populated landmasses that line up. So, once again, on the left-hand square map or other Pac-Man map, at least on the square one, it should be a rectangle. On the disk map, it should be a cone shape or a triangle almost. And on a ball, it should be a rectangle that's wider in the center. So this is, like I said, something I presented briefly on Nathan Oakley's channel a few days ago. And so that if you ever hear of somebody doing another track of the sun thing where they have people from all over the world reporting their positions and where the sun is, and instead of scattergunning and going all over the place, pick a confined area that goes as far north and south as possible, and you'll probably have a pretty good idea of what shape you're on. It wouldn't be a slam dunk by itself, but it would certainly be very telling, I think. But again, compare everything. And that's why I also have that list of cosmology videos that just the stuff I've done and in the description, along with a biblical cosmology one, which I did have somewhat of a hand in, not making the video, but doing the research. And the one on perspective and luminaries is, I think, one that was done by P-Brain, I don't know how many years ago, but it was mirrored on this other, excuse me, this other channel that has the main clip, the main points of it. So check those out. So anyway, like I said, I just wanted to present that on my channels that I presented on Nathan's and see what more people think about it. Not that I get a lot more viewers or anything like that, but I think we've gone up to 4 today. But it's an idea worth considering. Like I said, if anybody, kind of spread this around and see if anybody ever is doing another Track the Sun event, that they might want to consider this. Because I think it would be better than the shotgun approach to that sort of thing. So, that's all I wanted to say. Do you have any questions, either of you, in the chat, if you're still there? And, otherwise, I'll probably just shut it down because this was just a quick spur-of-the-moment thing I decided to do and have more people looking at it. So maybe people will view it later, especially if it's not too long. So there you are. And if there are no questions in the chat, I will go ahead and stop streaming. So thanks both of you for coming.